We have a proper, okay, going live.
Yep.
Welcome to the fourth talk of our data track today. I am happy to announce that we're talking today about writing the second wave open source relational databases. After a lot of practical and high-level theory, let's talk a bit more about open source. And I'm happy to introduce today Jan Karremans, the chief evangelist from EDB Postgres. Jan, take the stage.
Thank you. Good morning from wherever you are. Let me share my screen here to get this going. As we've got a lot of material to go through this morning. Again, welcome from wherever you are joining this beautiful conference here. Greetings from the Netherlands. I want to take you through open source, what it means for relational databases, how it all kind of fits together. And now I want to get it to move to the second slide. So this is very briefly about me. I've been doing databases for much longer than I care to remember, in all kind of different roles. And I've done some public speaking in the past in the community, getting people enthusiastic about some of the stuff that I work with on a day-to-day basis. I work for a company that's called EDB Postgres. We are basically to Postgres what Red Hat is to Linux. So supporting the community to kind of drive the adoption of Postgres, working with a lot of bigger companies to look at what is Postgres, how does Postgres actually fit into an IT ecosystem, and how can they make good benefit of that. And this is what I do on a day-to-day basis. And I'm very happy to kind of share some of the insights that we've accumulated over the last 15 years with you. And to kind of put that in perspective, I've started defining this a little bit as, waves of open source. And you might think open source is this fairly new thing, right? There in the last decade or so, a lot of these technologies have come up that are open source and that are taking the stage for a lot of this proprietary software. Well, actually, open source is not that new. Back in 1955, with the Share program, which was actually the very first open source program. At the point where we were able to separate a physical computer from the software that it was running, we actually had the opportunity to start making open source software. The first software was, these punch cards, and you could easily read it. So the source in that sense was open. So that started way long ago already. 1955, I said, the first SPLA open source project, followed by DKIS in 1980. DKIS from Digital Equipment Corporation was actually also a project that shared software freely amongst users, followed by GNU, the first real project that started driving open source in that sense as a motion, really as a movement. And my following slide will talk to that about as well, leading to Linux Torvalds, obviously, building, creating, and sharing Linux in 1991. GNU was actually created by this guy, and I don't know if you know who it is. It's a little bit hard to say, raise your hands if you recognize him, because we're virtual, unfortunately, still. I promise you this will get better, and we can do raise hands again. But this is Mr. Richard Stallman, RMS. He was the founder of the Free Software Foundation, so the first real movement that started propagating, open source, free software. There is this very famous other picture of him, which I couldn't find so quickly to share with you this morning, where Richard Stallman is standing on the separation lane of a highway, holding a sign, free as in freedom. It's not as much free as in it doesn't cost anything, but as we all know, running software always has a cost. but free as in freedom, having the ability to look at the code, having the ability to do adoptions to the software, etc., is something which is very much part of what is open source, this part of freedom. So taking the locks away and really making a change with software. So this first wave that actually started, what as we saw way back in 1955, actually was aimed at what you could define as easy to replace systems. If you're an organization or corporation and you need to start doing something different for whatever reason, right? Cutting costs, making agility, making changes. You start with things that have little risk. So when an editor, if you're writing a document, if you're writing a script or whatever, you use this editor today, and if it doesn't really suit you, if it doesn't really do what you want it to do, you switch to another one. This is something you can do very easily. It doesn't really have a big risk. It doesn't really have a big cost. It's a little bit of effort to get used to the new utility, to the new tool. So this is part of what I got to define as this first wave of open source. And that's actually been rolling over IT for a very, very, very long time. What we are seeing in the last years, and this is for me, personally, I joined EDB back in 2017. I did a migration from Oracle to Postgres personally as a DBA back in 2017. Sorry. For me, this was that second wave of open source, right? You saw systems that were complex, that are not so easy to replace in an organization, that actually have a big risk and a big value for an organization, being changed from proprietary solutions. If you look at IBM DB2, if you look at Oracle, if you look at Microsoft SQL Server, if you look at a bunch of these other proprietary solutions towards open source. First, because these complex open source systems had feature parity. They were ready to take on this next level. Again, for me, that was 2017. For a number of people, that was a little bit earlier. For masses, you really started seeing that hockey stick movement since 2017. So that second wave is really on complex systems. We are now in a world where we come to accept that open source and agile and those kind of things are part of our day-to-day life, and organizations are now able to kind of start investing in that and really embracing open source and these kind of systems. So in that sense, again, it's the comparison between closed versus open. Closed source software solutions as we knew them from the past were really built with this focus. I have a business, I build a solution for my customers, I sell this, and because of business reasons, I don't want to share the intelligence I put in the software with users or with the wider public. And that's not a value statement, because even today there are situations where organizations need closed software to be able to really invest in solutions. But on the other hand, we have more generally available systems that can be open. And obviously, a part of having an open source solution is that you can get so much more development power behind it, that you can build such more beautiful systems, if that's something you can call software. And I heard the moderator say, we're a coding conference, so I think the term beautiful code resonates here. Open source gives you the ability to come up with beautiful code, because there are so many people contributing. So that was that first part. If we now start looking at development cycles. And I took this from a presentation from Mr. Bruce Mongen. In his presentation, Will Postgres Live Forever? He kind of went through how does proprietary software lifecycle look compared to an open source software lifecycle. If you start looking at proprietary software, this is built by a company for users to use, and that could be the big systems of the past that we all know, right? It starts with innovation. You want to build something, you want to have something enthusiastic for your customers. So innovation is the first thing that's obviously required to get resonance in the market, to get people to buy your software, to adopt it. So the second stage in that is the market grows. People start buying your software, they're enthusiastic, start using it. But at some point you get to saturation. It doesn't really matter which things you further add to your software, which features or functions you build, because you can't sell more licenses. You know, if you run a system that is focused at, I don't know, a specific group of users, that's a finite group of users that are actually using your software, at some point, your market share, even if you have 80 or 100% of the market, they will all have your software. So you can't increase your software or put anything in that kind of sells more licenses. But as a business, you need to continue to make money because you have bills to pay, whatever. It's really a money-driven thing. So you need to start maximizing shareholder value, as it's written here. So you start doing new stuff. You stop doing support. You start kind of closing that down, because saving cost is the way that you can still make revenue on your software. And by naturally, the software gets in maintenance mode and kind of gradually goes into life. As Bruce said it's actually a sad story, because there is so much enthusiasm and so much power put in that software to begin with. If you now project this life cycle on open source software, it also starts with, innovation, with drive. I often compare it to somebody creating a script to do a tedious day-to-day task, right? I write a script. I give the script, I think it's a cool script. I give it to my colleague. Hey, colleague, I've got this cool script. Can you perhaps also use it to do your part of the business? And he takes the script and this is cool, but I would do this and this a little bit different and make it a little bit more efficient and give that back to you. Like I make these edits. In essence, that is open source, right? So you start with the same drive. I want to solve this business problem. I need something for that. And that actually gets you on the boat. And in my case, looking at Postgres, that started a long time ago. And, there was a lot of investment done in Postgres, and it grew and it got stronger. And we're now at a point where a solution like Postgres is actually feature parity, as written in the first one, with all the proprietary solutions out there. Feature parity, and in many points even ahead of. And the cool thing is, it's low cost, because the Postgres community, Postgres community doesn't have a dollar, a dime, anything, right? It's all done from within the community. But still, with that, you get this market growth. And because it's open source, it will continue to innovate. As long as that there are people that see value in your open source solution, innovation will continue. And even at the point where there is not so much general use for that open source solution, the code is always open. So the group, the masses are always able to continue building on the software. And that is actually a happy story in that sense. Another thing to kind of highlight here is open source community versus vendor-driven open source solutions. If you look at what Richard Stallman started, the free open source software group, if you have a community-driven open source solution like Postgres, the community decides, the community builds, the community manages. There is no company behind it that, based on shareholder value or other kind of drives, really say, you know, we need to build this feature in the solution, otherwise we can't sell more licenses. Really, Postgres couldn't care less about who uses it. They just build it because it needs to be in the software, because they need it for their operations, right? If you compare that to vendor-driven open source, it's actually still proprietary software. The benefit is that you can look in the software, so all the other good things of open source, in the sense of security, manageability, still fits, but extensibility, the innovation that comes from the community really doesn't pay into this. So that's a little bit sad in that sense. But again, just like building a closed source or an open source solution, it's really the scales. Where are my requirements? What do I want for my project? And which solution do I need? I personally am very happy that Postgres is this community open source solution, because you see it in the continuous innovation and all the stuff that's happening in and around Postgres still today, kind of to drive this forward. And this for me also was something that I learned only a little later. It sounds strange, but open source is really defined by the license. And this takes a little bit to think about. You would think, you know, it's open source, it's free, there is no license. Yes, there is. If you start looking at the Apache licenses, the GNU licenses, they all have things in them that, you know, you can use it, but you can't contribute without sharing back. There are pieces where you can look at it, but you can't resell it, etc. If you look at the Postgres license, the Postgres license by far is the most liberal open source license there is. If you're interested, go to postgresql.org and really look at the license, because it says, you know, you can take Postgres and you can do basically anything to it, and everything is allowed. You don't have to leave your name, you don't have to contribute back. You can even take Postgres, package it up, and sell it. And that's all allowed. So that makes for this massive body of technology that many companies can benefit from. This is also what you see in, and that's really taking a step into today. If you start looking at the big cloud providers, all of their cloud native databases are based on Postgres. Simply because the technology is there, it's being built, they don't have to have the expenses and the cost to maintain it, to extend it. So that is really something where this part comes in. But if you start looking at other open source projects, it's really key to quickly consider what the license is and make yourself a little bit acquainted with what that means. We've kind of discovered that, you know, community open source is a cool thing to do. One of the things that really fits in here is Metcalfe's law. You know, what it in essence says is, if you have a project like, in my case again, Postgres, the more people that get involved with it, the tighter knit the network gets, and basically the stronger the drive and the innovation for the solution becomes. I was with Bruce Momjian last week in Vienna at PGT Austria, and he gave that kind of same presentation, Will Postgres Live Forever? And one of the things he said, Postgres is able to continue its development in 5 directions at the same time. We build a software solution that has 180 new features every year. And it's not declining, it's growing. Simply because more organizations start looking at Postgres, more organizations start adopting Postgres for ever growing, ever changing business needs. So if you start looking at NoSQL, if you start looking at documents, if you start looking at machine learning, I saw that there were very many sessions on machine learning in this conference here. And one of the things is that colleague of mine, Dave Page, who is one of the core team members of Postgres, has recently done is a study on how can I run machine learning inside a Postgres database? How can I build something that actually starts analyzing, starts proofing data to really find meaning in the data? This is for me one of the indicators that, you know, Postgres is able to adopt, change, and fit in all of these changing challenges, just simply because more people start using this solution. And then stepping back, you know, this is a slide from well, 2 years, a year or 2 years ago that I created for the same presentation. I thought this morning, let me quickly check how this is looking today. And actually, you know, open source solutions have surpassed commercial license solutions. So this is again a very nice indicator that the thing that started so many years ago, right, where 1955 open source, then with the start of Linux, I think a bunch of you will remember those discussions, right? This is Linux. This is built by some of these weirdos, these nerds that smokes funny stuff in basements and attics, and they would build an operating system. And me, as a multinational organization, am supposed to run this operating system thing that they build for my mission critical solutions. That's crazy. Meanwhile, each and every organization runs a multitude, it's like between 60 and 80% of all server installations in the world today run Linux. This same thing is happening with databases, relational databases, other kind of database solutions, data management platforms in general. And this is what we see here highlighted again. Same with the number of systems that are actually running open source licenses. This also increased compared to last year. More and more commercial licenses are being pushed to the back a bit, simply because the agility, the innovation that you have within open source solutions really helps organizations get ahead and get that competitive edge. And basically, if you start looking at waves, then I was thinking, you know, you got wave one, you got wave two, there is this nice beach. And actually, if these kind of start coming together, you will get a surf, right? And we can start riding the surf. What I mean with that is replaceable technologies come together with these new found open source, more complex systems, wave one, wave two, splashing together. So basically, DevOps and all of these things are a very nice exemplification, if you like, of this first and the second wave coming together. I think it's actually nice if we could just double click or dive into that a little bit. So I thought I'm going to make a list, right? Of open source projects that are out there that could be of interest for this presentation. Oh my God. I just looked at libraries.io. Library.io has 4,698,492 open source packages across 32 different package managers. Wow, that's quite a bit. And it's not even the complete list because it's just only libraries.io. So, you know, okay, that's cool, but then I'm gonna zoom in a bit because, you know, this goes really all over the place. So I'm gonna focus on databases. Greenplum, DataStax, Yugabyte, Cockroach, Cassandra, you name them, they're in this list. They're all open source. Mind you, that might be open source and vendor-driven open source, right? MariaDB really is, or MySQL in that sense, is really a vendor-driven open source solution. Think back of the beginning of the presentation. So that is really something to be mindful of. There is a lot of open source power in the database area, and obviously in the middle, a bit bigger as the rest for me, Postgres. And I will get into specifically why Postgres a little later on, but this is an overview of just open source databases. Then another kind of cross section you could make is, if I look at my IT operation landscape today, which pieces in there are actually open source? So from software development, software lifecycle management, ticket management, web servers, operating systems, CI/CD management, the database, to Nagios for monitoring, ITOP, Kubernetes. These are all open source solutions. Kubernetes especially, as it's also a community-driven open source project. Very powerful, very complete IT landscape you can build today using purely open source solutions. And that's kind of what a lot of us are doing already anyway, right? So it's nothing new. And adding that final step to really start adopting a data management platform like Postgres as a key element in your open source IT landscape is really something that kind of makes sense, right? One of the other aspects of this serve, if you like, is if we have all of these open source components in our IT infrastructure, we really start doing a paradigm shift on how we build applications, how we look at what we used to build as this big monolithic solution, right? Back in the old days, it was waterfall programming. You started with a design, you built something, you started testing it, you did some modifications, you talked to end users, you did user acceptance, voila, you had a application built. That's not bad, but it's really a traditional way of a time where an application was this big locomotive, right? You were in an organization, you had an ERP system, you needed to look at storage, at what the things you had in stock, and there was this very rigorous business in your organization that really described, how do I purchase something, where do I store it, how do I get it on the truck, how do I get it to my end customer, what does invoicing look like? And that was this really robust, really stringent solution that you build, and it just moved forward. Things in IT today are changing so incredibly fast. If you look at the marketplace today, if you look at changing requirements, if you will all have seen these graphs, right, where companies that over time give you the overview of companies that rise and go under, and you will see first there were these traditional old-fashioned companies that did these traditional things that came up, and then over the years they kind of slipped away, and then companies like cloud providers came up and they went away, and it's now like these agile companies that you would never have expected to really take over the world, have taken over the world, and these are built on things that are a lot more agile. That has an impact on how we work together in the world today. And that also means, we have to look differently at how we run these things. So if you start thinking, oh, cloud, I need to go to the cloud. I have my solution here. I'm going to put it in the cloud, right? But that would look a little bit like this. As I talked just before this discussion, I've worked in Hamburg for a couple of years. And actually, when I walked to my office on every Tuesday morning, I had a straight view on the approach path to the Airbus works in Hamburg. And I actually could see this Beluga plane come in, land with new fuselages from Toulouse in France. Um, it works, but oh my God, is it ugly. If you start taking your traditional ERP system and put it in the cloud, you would end up with something like this. It works, but oh my God, is it ugly. What the cloud, what this new paradigm is actually requiring from us is to build something like this, you know. If a bird goes left, if one bird in the flock veers left, all of the others will veer with it to the left. A little bit more, a little bit less, but it's like we don't collide, but it's like this elasticity between all of these individual granules, and you get this beautiful movement of all of these individual specks in the sky. Super beautiful to see. And this is actually how modern applications work or should start working. If you really start looking at implementing microservices architecture, this is what you would end up with. It's this virtually neurological network of things that are put together and that kind of work together. But it's incredibly complex if you look behind the scenes, right? You have all of these different bits and pieces you need to start building together, individual microservices, parts of them linked together in these sagas. You need to have infrastructure, you need to have a lot of application parts underneath to be able to make this work. So that part is really an implementation of that second wave. And if you then start looking at taking machine learning, for instance, in your mind to really get information from data, you will need to be able to analyze data. And in that sense, I think SQL in itself will never die. I'm a relational database guy, and I can spend an hour talking about this graph. It's a very painful eyesore chart, but what it basically, the basic message it wants to tell is relational databases are nothing new. In the early 70s, Christopher Date and Theodore Cott wrote relational database theory. They had the opportunity to implement that in System R with IBM. So IBM really is the mecca of relational databases. They built DB2 out of it, and you know, all of this further development came out of that part. In that same area, we had a guy running around looking for a solution for his project for the US government. The government project was the CIA. His project was actually codenamed Oracle, and with that, you know, that guy was Larry Ellison. He took relational database theory, implemented that, and created Oracle. In that same time, there was a guy called Mike Stonebreaker, also in the Bay Area. He was looking for a solution to start building at the University of Berkeley, and he actually took relational database theory to make Ingress, and from Ingress he came to the post-Ingress project, which ended up as Postgres. So Postgres, as well as Oracle, as well as IBM's DB2, all in the end come from this relational database theory. What we see in our customers is that actually 36% of our customers are using Postgres as systems of analysis. So that could be perceived strange, right? Using a relational database to really do data analysis, but this is really what we see, and 54% are using it for systems of a record, what it was originally intended for. With this huge surge of data and the explosion of it, it's really like this, right? You start doing it and you get blown away if you start looking into data. Data today is so humongous and so vast. This is what we're trying to manage, all of us here together in this conference, where data is really at the heart of everything we do. Data grows like crazy. Big data originally wasn't really about many data or much data, but it was really about getting the bigger picture of data. But big data leads to more data. We're capturing zettabytes of data. It's really, really exploding in that sense. What we see is also a proliferation of in this data area. So there are so many more data sources today. There are so many other ways to store data. There are so many other ways to process data. Everything is aimed at, I have this influx of data, I have this body of historical data, I need to make sense of it. How can I start working through this? How does this start helping me? And in that sense, relational still rules. I have the ring from the Lord of Rings, one language to rule them all, or one language to bind them, if you like. And NoSQL doesn't mean NoSQL, it means not only SQL. So if you start thinking about this, even in things like machine learning, even in things as, for instance, the way that MongoDB goes after this, schema on read, schema on write. The key word is schema. In the end, to be able to make sense of data, you actually have to be able to really work with the data, to be able to query it, to interpret it, and to work through it. And structuring data afterwards is very expensive. I did an exercise together with a good friend of mine, Brendan Tierney from the University in Dublin, really to start looking at what actually is it, these MapReduce jobs that you send out. And what for me personally kind of appeared was, if I do this, basically I'm sending out 5 queries, and the first query that comes back wins, and I'm going to work with that result, and I'm going to disregard the other queries. Basically saying, I spend $500, the first $100 gives me a result, and the other 400 I'm just going to burn because I'm not going to use the results that they come back with. That for me was the business interpretation of actually what is big data messaging. If you map that back to 1974, very, very long time ago, there was the great debate that actually did the discussion between hierarchical databases and relational databases, network or document databases, versus relational database theory as it is implemented in Postgres. And actually, relational database won. If you're interested in getting more information on that, you can read this blog, actually written by Mike Stonebreaker, talking about this a little bit more in depth. So coming to the end of my session, what does this now actually mean? We've seen like 35, 40 minutes of a lot of mumbo jumbo around open source databases, data, and how do we tie this together? If you look at it from a business perspective, open source will help you reduce dependencies. Reducing dependencies for a business is important because you get more flexibility. If you don't have very expensive contracts with software vendors, if you're not dependent on what they will be able to build for your software solution, it frees up basically anything. You can, if an open source solution doesn't do what you need it to do, this was actually a discussion we had with a bunch of customers a couple of weeks ago. If Postgres, in this sense, doesn't do what you need it to do, you can step up. You can say, as a company, I'm going to contribute to the project. We've seen the Metcalfe's law thing, that the more companies that contribute, the more flexible the program becomes. You can start contributing. I can make changes to Postgres, hence gaining flexibility. And because you're using open source solutions that are being built at no cost, and please don't make the mistake, open source is free, as in it doesn't cost anything, but it's helping you to significantly reduce costs. So this is a business value for choosing open source. If you look at operations, we've seen the slide with all the different bits and pieces that are in an IT infrastructure today. You get the ability to mix and match everything, somehow fits together. And again, there is no silver bullet, right? That will one solution that does everything for you. You're able to mix and match exactly the things that fit your project, that fit your business needs. And because it's all built by these people, they have a tendency to really adopt standards, because they benefit if their software is being used, so they will make an effort to make it fit together. It fits in into changing standards. It fits into deployment standards, so really rolling out software using open source solutions like Ansible, etc., to install and provision software. And then finally, from a developer standpoint, you can really start focusing on opportunities and not the limitations. In the past, I have led software projects that were built on solutions that you would buy because there wasn't anything else at that time, and you were really seeing, what can I do with it, and where are my limitations? How do I need to work around these limitations to get my product to do what it needs to do? And if you're a developer, it gets easier to extend and expand the tools that you're actually using as you see fit to really make them work and behave and kind of help you get the result that you need. So basically, that is what I had prepared. It's a wrap. And with that, I think I will open up for questions if there are any. And looking at the Q&A screen, I don't see any.
Hi, Jan.
Hello.
We're close off to 3 more minutes. Super interesting again from my side. Sadly,
Cool.
we have no questions from the audience yet. But I'll take it as a big shout out to all the people actually working on open software and using it. It's helping us do our work every single day, and we wouldn't be there today where we are without it. So thank you for this talk of how to approach it with a more holistic on context. All right. Since there are no questions for now, I'll close up the session and move up to the next one. Again,
Cool.
Jan, thank you very much. If you do have some questions or want to follow up with Jan directly, use the Pinecast platform or feel free to use his contact details. For everything else, thank you very much for your time and attention, and I'll see you in the next session. Thank you.
Thank you. Bye-bye.